Hello my friends, this is Mike from Seawater Pro. This is another quick video. We're going to go over the new water pre-filters. We just got those pre-filters in and I think they look really good. And I'm just going to go over one more time the dual membrane. Also, hey, by the way, these pre-filters have a little bleeder port here. Sometimes when you see air, eventually it will go away. You don't have to, but you could very easily get rid of it by opening this little cap here. Let's talk a little bit about our latest control panel. I don't know how old your system is, but since January of this year, we have we're using our new patented pressure regulator. This is not a cheap needle valve like some other guys use out there. This is a real pressure regulator. It is a spring-loaded mechanism. If I may take it apart, I'll show you what I mean. Okay, there's a spring in here. Okay, this spring is so it keeps a constant pressure, and it also absorbs hydraulic shocks. A hydraulic shock is when your boat tilts over to the side, or you go over a wave and you gobble up a pocket of air. What happens is the pocket of air travels down the membrane, and when it reaches the pressure regulator, it changes speed. It goes from whatever 10 miles an hour to 150 miles an hour, which is fine. The problem is right behind this air pocket comes what? A wall of water that's now traveling at 150 miles an hour. Slams on the pressure regulator, and if you don't have a needle valve, and you don't have the spring-loaded automatic pressure regulator, you're gonna damage either your hose, your membrane inside, or you're gonna crack your membrane housing. I have pictures of cracked membrane housings, and that's why we don't use the cheap Chinese membrane housings. That's why we use these stainless rods on the outside. We went away from the old Chinese fiberglass because they ended up cracking. We had a few failures and we discontinued use of those. So if you see a Watermaker out there that has white fiberglass housings, if the ones that I've seen, they will eventually fail. Please be aware. These long rods act as springs in case of a hydraulic shock. These will actually, you will notice a gap here when you put the system under pressure. This gap is from flexing of these rods. These rods flex intentionally to absorb hydraulic shocks. If you have a residential system, you don't need to worry about hydraulic shocks. You're not going to be jumping over waves. If this system is in your boat, you do. Believe me, we've seen those, and we've worked out this problem. So you will not have a problem with hydraulic shocks if you buy a Seawater Pro system. Back to the pressure regulator. One more really cool feature about this pressure regulator is that it has a built-in blow-by, meaning that it always leaks a little bit of water. This is where we have the patent on this pressure regulator, and this is the significance of that. So you leave your pressure regulator set for 800 psi, and when you operate your system and you're done making water, you do not have to relieve the pressure. Leave it set at 800 psi. Turn the system off. You're done. There's nothing else you need to do. When the rinse timer kicks on, it will self-rinse the system regardless of the fact that this pressure is set for 800. Leave the pressure. So when you're ready to go back making water, you turn on both pumps. Now you're making water. You don't have to relieve the pressure. There is no need to worry about hydraulic shock because of the things that I explained a minute ago. Remember the spring absorbs, how it absorbs hydraulic shocks? That is also when you turn the system on and off. And so this system, without need of any electronics, which we all know what happens to electronics in your boat, you can operate the system on simply by turning off both switches, the boost pump, and then when you're done, turning it off. There is no other need to adjust anything or worry about anything. Okay, back to the boost pump. Just a couple of notes here. This little box, it is in line. There is like a 3 meter or about a 11-foot cord between this box and the boost pump. Do not cut this cord. This is not just a junction box. This is a 3-phase converter that makes the brushless boost pump operates. So do not mess with the cord between this and the boost pump. Here is where you connect the power. There's a black and a red, and this pump runs from 12 to 30 volts. And if you want to run it at 110 or 220, all you got to do is ask. We have a little power supply. It's a 10 amp power supply, which is about twice as big as the pump requires. It will run 2 pumps. It looks, it's no bigger than a laptop charger. It runs at 220 or 110, and it will operate your boost pump. So for those of you who have 12 volt systems, you don't need this. Those of you who have 110 or 220, this is all you need to run your boost pump at AC. Another question that keeps coming up is, do I need a control panel or do I not? Well, here's what happens if you don't want the control panel. If you have easy access to the membrane, if you, let's say you install the membrane in your engine room and there's plenty of room to go around and inspect, check the pressure, adjust the pressure when needed, check your TDS analyzer, look at your fresh water flow. If you have easy access to all these things, you don't need a remote. You can just save yourself the $500. Everything bolts on the membrane. At the end of the membrane, you mount the pressure regulator, the gauge, the flow meter, everything else, everything you need. And so, again, this is what you get with the remote control. This remote control is an additional $500. Here is a system without the remote control. Here we are. These are the electronics. This is the wall of shame. These are customers that brought back their old Watermaker. They wanted to use our dumpster. They bought one of our systems because it was cheaper to buy one of our systems than replace the electronics that kept breaking every time they would use their system. So let me tell you, we are doing all that complexity without any electronics whatsoever. Let's talk about our DC systems. Here is a 12 volt motor made by Leeson in USA. Here is what the brush inside this motor looks like. This brush, we've had motors out there for over 5 years and they're still running on the same set of brushes. These motors are designed to put out 1 horse. We run them at 50%. We use a smaller pump. So instead of 80 amps, which is what the motor is capable, we only draw 50 amps. That's 600 watts. With 600 watts, we're making 17 gallons per hour. I know there are systems out there that use a lot less energy. They make a lot less water. Some systems have energy recovery. Energy recovery increases the complexity, meaning there's now 2 pumps involved instead of 1. So expect double the maintenance, double the problems. We choose simplicity over energy efficiency simply because the solar panels are 10 times cheaper than they were 5 years ago, and lithium batteries have come down at least 40-50% in the last 12 to 24 months. So the energy is not so much of a problem anymore like it was 5-10 years ago. So another thing is that you're going to run the system for an hour a day and you're done. A smaller system that draws maybe 200 watts or 150 watts, you're going to have to run it 5-6 hours a day. So in the end, you're not really saving any energy. You're just paying for extra parts. The 12 volt system, again, by the way, we have these motors available for 24 volts and 48 volts. So for residential installations that run 48 volts, you don't have to go through an inverter. You can just run straight to the motor. That increases your efficiency by about 20%. One more thing, the 12 volt systems, this question keeps coming up. The 12 volt system is limited to a single membrane. That's because we don't want to run this motor at 100%. If I were to put a much bigger pump on this motor and load it up, yeah, I could run 2 membranes. I just can't do that with a 12 volt motor. There's going to be a lot of arcing in the brushes. I choose to sell a more reliable system than a system that takes chances. Now, when it comes to the 24 volt motors, those we use the bigger pump. In that 24 volt system, you can go with 2 membranes, which is what you see here. So imagine this system with the remote control and a 24-volt motor making 40 gallons an hour, and you'll be using about 900 watts of power. That is at 40 gallons per hour. Let's talk about pricing structure. What you see here is our base model. This base model is 110 or 220 volts. We also have a motor that runs at 50 hertz. Please, if you guys have 220, you're from Europe and you're using 220 volts and you need a 50 hertz motor, let us know. We will swap out this motor for a 60 hertz motor. Going back to the system, single membrane, 20 gallons an hour, 110 or 220 is $2,995. You have two options to the system. You can add the second membrane. It requires no other change. Same pump, same motor, just add another membrane, adds $500 to the price. If you want the remote control, that's another $500. So our pricing is very simple, $29.95 plus $500 for the second membrane, plus $500 for the remote. Now, pricing on the 12-volt systems, we had a price increase. Much like everything else these days, things are going up. Our suppliers are raising the prices, and we have to follow. The 12-volt system just went up in price from $2,995. It went up $250, so it's $3,250 right now for the 12-volt system. Any DC system starts at $3,250. And again, if you go with the 24-volt, you can add a second membrane plus $500. Now you're up to 40 gallons an hour. Let me say that one more time. 24-volt systems can support two membranes, and you're up to 40 gallons an hour, and that's for an additional $500, and an additional $500 now gets you the remote. So a DC system, $3,250 plus $5 for the second membrane, plus $5 for the remote, and you have yourself the fully loaded 40 gallon an hour system.